Hello, my wonderful students. Welcome back to your science class. So, my dear students, today we will complete our chapter by doing our D part. So, students, today we will complete our D part of our chapter number 8, that is physical and chemical changes. So, I want everybody open your science notebook, watch the video, and write the answers along with questions in your science notebook neatly. So, let's start our questions. I hope student, each one of you have opened page number 93. So student, today we will complete our D part, that is long answer question, answer these questions. Right, so let's read question number 1. So I want every one of you watch this video and write the answers in your science notebook neatly. Right, students? So let's read question number 1. So question 1 says that discuss the methods by which rusting of iron can be prevented. Now you have to tell the methods by which rusting of iron can be prevented. So the method can be, first is painting. By painting we can prevent, like a coat of paint applied on the surface of an iron object prevents oxygen and moisture present in the atmosphere from interacting with the iron object, right? So second is oil or grease. If we can put oil or grease on the iron, we can also prevent it from rusting, right? Applying the oil or grease on the surface of iron tools helps to keep out the oxygen and moisture of the atmosphere. Third is galvanization. So through the process of galvanization, student, we can also prevent rusting, right? So it is the process of coating iron object with a thin layer of metal such as zinc or chromium. A thin coating of zinc or chromium protects the iron from rusting, right? So let's move further to question number 2. What does question 2 say, students? So question 2 is, which gas is given off when dilute hydrochloric acid is added to calcium carbonate? Now you have to tell the name of that gas when dilute hydrochloric acid is added to calcium carbonate, right? And also you all have to tell that how will you test the gas. Now how will you test that gas and write the chemical equation of both the reactions. So student, the answer is that carbon dioxide is given off when dilute hydroxide is added to calcium carbonate. So the equation is CaCO3 added in hydrochloric acid gives us CaCl2 plus H2O plus carbon dioxide. So this is the equation for this. And second is carbon dioxide can be tested by passing it over lime water. It can also be tested by passing it on to lime water. So lime water, students, turns milky in color. So the equation involved is the lime. When we add lime and carbon dioxide together, it will give us calcium carbonate plus water, right? Lime formula is CaOH whole 2 plus CO2 gives us CaCO3 and water, that is H2O. So student, the calcium carbonate formed in the reaction is white in color and not much soluble in water. So student, it gives milky appearance and is used as a test for the presence of carbon dioxide, right? So moving further, question number 3. Now students, read question number 3. What does question 3 says to you? So question 3 is that explain the steps involved in preparing the base magnesium hydroxide from the metal magnesium. So now you have to tell the steps. Which steps are involved in preparing a base of magnesium hydroxide from the metal magnesium? So the answer is, first of all, what we have to do is we have to take a small piece of magnesium ribbon, right? Then clean its tip with sandpaper. So hold it with a pair of tongues and bring it near the flame. So what happens is that it burns with a dazzling flame and forms a powdery ash. And that powdery ash is, student, magnesium oxide, right? Next we have to do is collect the ash in a test tube. That ash, which is powdery ash, is obtained, and we have to collect that in a test tube and mix it with a small amount of water, and we have to stir that, right? Then when magnesium oxide dissolve in water, student, it forms magnesium hydroxide, and the equation involves this is the equation. See, what is the equation? 2MgO, that is magnesium oxide plus water, gives us magnesium hydroxide. This is the balancing equation. 2 to 2 is the balancing of the equation, right? So gives us magnesium hydroxide. So let's move further to question number 4. So what does question 4 say, students? Question 4 is a decomposition reaction is the opposite of a combination reaction. So you know
Combination reaction is the opposite. The opposite of combination reaction is a decomposition reaction, right? So now you have to explain this statement with the help of an example, right? So the answer is the reaction in which a compound breaks down to give two or more simpler substances. So what is decomposition? As the word decomposition says, then when a reaction in which compounds breaks down into two or more simpler substances, student, that equation or that process is known as decomposition. For example, we can say on passing an electric current through water, when we pass an electric current through water in which a small amount of sulfuric acid has been added, water decomposes to give hydrogen and oxygen gases. This is the equation. H2O gives 2H2 plus O2. 2H2O gives 2H2 plus, it is breakdown into two or more simpler compounds. When we break water into simpler compounds, so water is broken down into two simpler compounds and H2 plus O2, right? So the reaction in which two or more elements combine to form a single compound, student, that is known as combination reaction. For example, see students, in the above example, H2O is broken down into two simpler compounds. That is when we break single full compound into two or more mixture. So that is a decomposition reaction. And when two or more elements combine, when we combine the two or more elements together and the result is a single compound, that is the combination reaction. That means with the help of a two elements, when they are combined together, we get a single compound. So see here the example, H2H2O plus O2 gives us 2H2O, right? From the above example, it is clear that a decomposition reaction is the opposite of the combination reaction, right? I hope it is clear, student, now. Okay, so moving further, question number 5. So what does question 5 say, students? So question 5 is, under which two conditions do decomposition reaction normally take place? Now you have to tell the two conditions where decomposition reaction take place. So give one example for each. So the answer is heating and electrolysis, right? So heating is then when calcium hydroxide is heated, calcium oxides and steams are produced. So this is the first condition, student. See, when calcium hydroxide is heated, it gives us calcium oxide plus water. Second is electrolysis. What happens in electrolysis, student? When electric current is passed through a molten aluminum oxide, it undergoes decomposition to form aluminium and oxygen gas, right? See the formula. 2Al2O3 gives 4Al plus 3O2. That means aluminium, two aluminium, what are these? Two aluminium oxides gives us 4 aluminium plus 3 oxygen, right? So moving further, question number 6. What does question 6 say, student? Question 6 is, what is a displacement reaction? Now you have to tell what do you mean by displacement reaction. Which rule governs displacement of an element in a compound by another element? Explain with an example, right? So the answer is, first of all, you have to define displacement reaction. So in a displacement reaction, one element replaces another element from a compound, right? Generally, a more reactive element replaces a less reactive element from its compound. For example, iron is more reactive element than copper. If a piece of iron is added to a solution of copper sulfate, iron sulfate is formed, copper metal get deposit on the iron pieces, as you can see from the equation. So this is the equation, student. Copper sulfate added in iron gives us iron sulfate plus copper, right? So moving further, what does question number 7 says? So question number 7 is, what is a double decomposition reaction? How many types of double decomposition reaction do you know? So you have to give one example. So student, double displacement reaction is there where two elements are used, as the word double displacement says. So a reaction in which two compounds react to form two other compounds by mutual exchange of atoms or groups of atoms is called double displacement. So the example is the precipitation reaction. As you can see here, when sodium chloride is added on silver nitrate, it gives us silver chloride and sodium nitrate, right? So second is neutralization reaction. It is, so everybody can see here, neutralization reaction is that when hydrochloric acid is added to potassium hydroxide, it gives us potassium chloride plus water. So this is through the process of neutralization, right? So moving further to last question, that is 8. Explain the terms oxidation and oxidizing agent. Now you have to explain the term oxidation and oxidizing agent. So student, oxidation is a chemical reaction that involves addition of oxygen or removal of hydrogen from a substance. For example, when carbon reacts with oxygen to form carbon dioxide, it is said to oxidizing, oxidized by gaining oxygen, right? It is oxidized by gaining oxygen. Similarly, when hydrogen sulfate reacts with chlorine, hydrogen sulfate is said to be oxidized to sulfur by loss of hydrogen, as you can see from this equation. So student, an oxidizing agent is one that oxidizes other substance either by providing oxygen to them or by removing hydrogen from them. So with this, we have completed our chapter. I hope everybody understood the chapter. And now student, I want your work to be neat, right? So thank you.
I hope, student, each one of you have written the answers neatly and correctly in your science notebook. So till then, take care, stay home, stay healthy. Thank you so much.